today are going to be the Roloc bond technology that utilizes a brick that is produced locally, and that is the Roloc bond brick. All this in the, let's say, under the wings of the project Proeco of SCAT, which, as someone mentioned, aims at facilitating and improve the current conditions in the market supplies for bricks specifically, in this case. And we can see how the brick itself can be an actual driver for an improvement in the quality of the built environment of Rwanda, as well as a more sustainable tool for the construction industry in Rwanda. So we are going to be facing two phases of this topic. The first one is the brick itself, and we will see briefly how the brick is produced at a semi-industrial level or in situ level, or very small production level, and then how this brick is applied into the Roloc bond technology with some built examples that you've seen already in Samo's presentation, and that everyone can actually see firsthand by visiting projects in Kigali already, for example, in Kimisagara and in the Mpazi area, between Kimisagara and Gitega, in the valley behind the bus stations. So we will see how the low carbon clay brick production somehow happens at different scales. And then we will focus on the Roloc bond brick, and then how we build a wall with this specific technology, how we actually reinforce it for structural stability and seismic earthquakes, seismic events, and how this actual construction is thought with the idea of having a load-bearing wall in mind instead of a classic load-bearing frame and infill. And then we'll see how the actual construction, a Roloc bond construction, develops into a building. So with floors, with MEP integration, with all the other components that make a building at its final stage, and a usable product. Always thinking about the idea that it has to be as sustainable as possible, because we have to move only towards the goal of sustainability and reduction of carbon output. And hopefully this is one of the ways that in Rwanda we can follow to achieve that. So everything, as I was mentioning before, revolves around this special brick. It's a brick that is not super common in Rwanda, but you can see more and more projects that starts to adopt it. And it's a brick that is produced industrially, but also semi-industrially, and from also a very, very small producer. And why is it so important? First of all, the difference between this brick and a regular locally produced brick is that it's extruded, so it has precise dimensions that are consistent throughout the batch of production, and it's perforated. Thanks to the specific construction process, the bricks are perforated, and the perforation gives the opportunity during the firing process for the brick to be fired evenly within its entirety. So that leads to what is important for us, which is compressive strength, which is high enough to be a load-bearing wall, to become a load-bearing wall. So we have an average of 10 megapascal of compressive strength compared to the 3 to 5 megapascals of a regular brick. So you already see where is the difference, the huge difference there. And that is achieved mainly through a very good firing process. So overall, we have a reliable performance that every producer can go and tap into in order to build, to develop any construction project. At the same time, in order to produce this brick, we use 6 to 8 times the less amount of energy to fire it. And this is what ties into the what I was talking before about the sustainability aspect that we have to strive for. We have to find as many possible solutions to reduce the carbon emissions and to find more sustainable materials for the future of the construction industry, especially in this country. So this brick leads us to, what are the main differences between a classic brick or a traditionally made brick and a modern brick or a semi-industrially produced brick? The main difference is that one is extruded, the other one is formed somehow with a mold, but moved by hand. And therefore, what I was saying before, the dimensions are not even and are not consistent. In order to have a qualitative finish, it's important that the material, the final product, has reliable dimensions. And secondly, it's fired in a controlled environment. Therefore, it's fired in a kiln, or we can call it an oven, with whom is not familiar with the kiln terminology, in comparison to the local production, which is fired in a non-controlled environment and with fuel that is unsustainable. The fuel generally used is either charcoal or firewood, mostly eucalyptus or any other firewood that is available in the area. And this is definitely not a sustainable solution for a firing process. And it's also a very bad qualitative product that is the output of the process, because the inside of the fire pile is overcooked most of the time, overfired. The outside is underfired because barely any heat reaches the outside. So as you can see, the difference in the firing process is extremely important to achieve a good product that we can use for our projects. We will see here very briefly, because otherwise it's going to take the whole day, how the brick production happens roughly. And we can see it in a fairly large scale, as we can see now, and in a smaller scale later on. This setup is for a semi-industrial production, which is somewhat of a smaller scale than the Ruliba factory that we all know, but that has a clay bank, so a clay storage of about 4 or 5 months worth of production. It has machinery that extrude the bricks, and so we have a high output of bricks extruded every day. And it has a kiln that has the capacity of producing 2 to 3 million bricks a year. So a sizable quantity that, although of course also requires a fairly skilled labor and also a sizable investment at the beginning. And the production is generally speaking taken through a zigzag kiln that allows for a continuous firing process that never stops until the batch is completed or the unfired bricks are completed. But what is probably more interesting from a development perspective, also from a small scale developer or architect or engineer, is to see how we can apply somehow the same technology of brick production in an extremely small scale in situ. or not only in situ, but in a very fairly small plot of land that allows to produce us roughly 300,000 bricks per year. And it's a setup that is extremely easy to set up and to start. As we can see here, we have the supply of clay at the beginning, and then down the chain of production, we have the extrusion on number 3, on the drying process of number 4, the firing process of number 5, and we have the ready product on number 6, which is at 0 kilometers transportation to the site of construction. So we can see here, this is the very ideal situation that we could have, where the construction material is produced right where we need it. Of course, there are all sorts of ranges between a semi-industrial production that we saw before and the in-situ production. They can be everything in between. Of course, we can see these two as the two opposite ends of the production typologies. But for sure, the in-situ production is what probably a small medium project could strive for because of the reduction in cost of transportation of the material, in sourcing of the material, because most of the valleys that we have in Rwanda have some availability of clay. And of course, anyone that is interested can refer to SCAT, that has a huge database of information about where the clay banks are available in the country. But already in Kigali, if we think about Kinyinya, we think about Kanombe, we think about Gahanga in the south. All those areas already have available clay banks that can be tapped into, and those areas are already 3 areas where many projects might happen, or many projects that you are working on might be happening. So as you see, as how easy it could be to have the raw material brought on site, either with trucks or by hand, and then have brick produced locally at a very low cost and with a production process that is much more sustainable than a traditional construction material. So the production process takes us from the valley, from the clay banks, where we fetch the clay. The clay is selected and then transported on site, where it's collected and led to weather for a certain period of time, and then prepared to be transformed into the product. So the clay is mixed with water in the right ratio, so in order to have the right consistency for the machine, then it's loaded into the machine and extruded into the precise size bricks that we are looking for. The bricks are therefore stored in an area where they are dried. There's a primary drying phase and a secondary drying phase that the bricks go through in order to achieve the right humidity level, which is as low as possible, of course, before being fired in the kiln. Here we have an example of a kiln which is built in situ, so is built right next to the construction site. The kiln then is reused as a septic tank. So it works as as a kiln at the beginning, and then it's transformed into a septic tank later on. So you see, and it's another level of convenience for someone that is looking to develop a product of this level. The kiln has chimney, and this chimney is the only thing that then is removed from the kiln and then reused in the next project. So the green products, the unfired products, are then loaded into the kiln in a very specific way that allows the firing process to take place. And extremely important is the fire combustible that is used. So the combustion happens through the firing of either rice husks, coffee husks, and sawdust, which is leftover materials that normally are discarded or used in other fields. But in this case, instead of using charcoal or firewood, we can use in a much more sustainable way discarded fuel in order to complete the firing process. The firing process takes place in a very controlled way, where the temperature is always controlled in order to make sure that the heat inside reaches a certain temperature and make sure that the bricks are fired correctly. This process presents not only advantages in the quality of the product, that is the output of the process, but also it's much more sustainable for the workers on site. As you can see in the two images, one person is covered from the rain in an environment that is much more conducive for the work, instead of being exposed to the weather and in a production process that is extremely dangerous for the health of the worker. Once the firing process is completed, the product is taken out of the kiln and stored properly on site before being used. As we can see here, this is right on site. The bricks are taken from the drying stage to the fired stage in a very short distance, let's say. And we have an example here where we can see the production takes place right next where you see the mason building something. So this is as I was saying before, probably the most ideal situation when it comes to construction materials, because the production is right next to the utilization of the material. So in terms of sustainability, this is a big step forward, let's say. So this production, chain of production, allows us to create sort of an holistic cycle where instead of using the standard and most common cement block that requires cement that is most of the time imported or in a large quantity imported, and allows us instead a production of a material that is controlled locally. And this allows many other local producers to grow, because they see that they might see that the market is thriving and there's a need for those kind of materials that are cheaper than the standard blocks. And this creates a cycle of where a lot of sectors can start benefiting, not only the construction material sector, but the job creation sector. And sustainability is also a benefit of the process.